Lead exposure is a serious threat for many Americans, whether it's old paint in our homes, water exposure, or from the soil.
Yikes.
And so many departments of health at a state level will measure the blood lead levels, and through that process have a way to surveil the amount of lead in our systems. And so if I show you this data here from the California Department of Public Health, you can see that for each zip code, we have the blood lead levels of a 4.5 microgram per deciliter or greater in descending order by zip code. And I want to show you how we can process some of this data by leveraging the geographical information. Then at the end of the video, I think you're going to see one of the major issues that this kind of data can pose, although it is still quite helpful for some surveillance aspects. So in the far left corner, we have the zip code, the postal district, and then the lead levels for children under the age of 6. So to carry out this analysis, I simply copied this table, pasted it into Excel, and then did my data processing using Python. If you want to follow along, I do have this notebook in a GitHub repository at this link here, the Lead Data Cali Map IPython notebook. And I should highlight that the data for me is in this Lead Cali Excel, but in a data folder. And so if you want to repeat this analysis for yourself, you definitely want to ensure that this path is correct for you. Let's begin. This is the link where that source data can be found. And then I'm just using 4 different libraries: the Pandas library for data processing, Plotly for data viz, and JSON and URL-lib for actually getting some of this JSON data I need to help me build this data map. So to begin, I'm going to look at this lead data that I've just talked about. And as you can see, I've simply pasted that table, the zip code in the far left corner, and this first row are my header values. So I read that in, and I'm just going to use columns A, B, and D. So it'll be this zip code, this postal, and this percent level. Next, I want to show just the first 5 rows of data. What you can see here is that we have the exact same table, just with rows C and E excluded. And one of the major steps for visualizing this data that I want to demonstrate is that we can use other content from GitHub to allow us to put this data together visually. And so what we have here on this raw path is a link to another GitHub repository where we can use this information to help us understand where these zip codes are in a map. And thus we get this large JSON file here at this URL. And so I've used the JSON library to help me parse this out, which is essentially a dictionary of dictionaries. These JSON files are very useful for storing large amounts of information. So I'm going to open that file using URL open, and then pass in the raw path, create the response, and then store all that information in zip codes. That will take a few seconds to run. And when it's done, I will show you what zip codes look like once we parse that JSON file in our local environment. So now you can see what that file looks like. And so right now, this is the entire dictionary, or at least a subset visually of the dictionary. And I know I want the features key. So let me rerun this cell where you can now see what features will bring out. And then I will continue to reveal each level down so that you can see how we will decide where do we put the variables for the next step. So this here is the feature key. I now want the key 0 and properties. I will uncomment those at the same time. You see we have our state, our geo ID, and other aspects that are very important, including the latitude and longitude for a particular zip code. And then I want just this value here. And this here is a particular zip code. And the reason this is important is because we can take that information and add it to our choropleth plot. And to do that, I'm going to pass in this GeoJSON file as zip codes. I'm going to set the location to be the zip code column in my data frame. And then the feature key ID, the thing I want to demonstrate, is the zip code. So that is why we're drilling all the way down, so that we know we want our ZCTA5CE10, because this key is the key we're using in our data table because we have these zip codes in this column here. And so all this sort of plays together, although it could be a little bit complicated. Also, we want to establish the center of our plot. And because we know that this data is focused on California, the center of the plot should probably be near the center of the state. So simply, I went to a map and just approximated the center of the state, as you can see here, and then just selected the longitude and latitude of that point. So you can right click and see that this is the longitude at this particular location, and then you can copy that. And so I've already done that. I'm showing you where that location is that I've identified as the center, but you can choose any point. And obviously this could differ based on where you are in the state, in the country, in the city, but really important for telling the Plotly Express map where to center the visual. So back to our notebook. And lastly, let's just run this. All of this other stuff we've discussed, where the color scale being Viridis is very common. I'm just setting the hover data to be the postal district name, which will be effectively the city that these zip codes are located. I'm setting the scope to USA because we don't need a global map. And then I'm going to color by the percent of blood lead levels 4.5 or greater for children under 6. And so you can see here, this is our map. And you're already getting a glimpse of perhaps what some of the big issues are with this particular piece of data. It's very spotty, and there's lots of regions, particularly some of the more rural areas, where we're missing a lot of information. I know this because there weren't enough children who submitted blood, so they could not fully anonymize. However, this does highlight one of the challenges when it comes to getting data and trying to understand what are the risk levels in your area. And so in this video, you can see that Python is a great tool for data storytelling. Now, we could have just created a bar plot to show the relative levels by each zip code. However, by illustrating this data using a GeoJSON or a choropleth map, we're able to show where we have data and where data is missing. In any case, I'll see you in the next video. Peace.